Hello friends, in today's question, two bodies A and B of mass 10 and 5 are placed very slightly separated as shown in figure. The coefficient of friction between the floor and the block areas is 0.4. Block A is pushed by an external force F. The value of F can be changed when the welding between block A and the ground breaks. Block A will start pressing block B, and when welding of block B also breaks, block B will start pressing the vertical wall. So we have to find four things. First is, if F is 20 Newton, with how much force does block A press block B? B part. If F is 50 Newton, the frictional force acting between the block B and ground will be. C. The force of friction on B varies with applied force according to the curve. And the last part is, what is the minimum force F so that block B can be pressed against the wall? This figure, block A and B, A is 10, B is 5. Slight distance between A and B, and force F is being applied on block A. So let's first of all find out. Here it is called as welding. Basically this is somewhat related to the friction. Okay. So let's find out the various frictional forces that will be acting on block A and block B. You can say for block A, the downward direction it will be MAG, and in upward, let us suppose normal NA. It is force is acting from left to right, so friction will be from right to left. Let us call that FRA. So we can say that our FRA is equal to mu S into NA. Mu S is given at 0.4 and NA will be equal to MAG. Substitute the values. FRA 0.4, mass of A is given as 10, G is also taken as 10, so FRA is 40 Newton. Similarly, let's solve this for block B also. For block B, downward direction there will be MBG. In normal, let us call that as NB. Frictional force, let us call that FRB. So we can say that our FRB is equal to, coefficient is same, multiplied by NB, which is equal to 0.4 multiplied by M, mass is 5, which is 10. So we get this as FRB will be equal to 20 Newton. So these are the two frictional forces which will be acting on the respective blocks. So in the first part, we are supposed to find out, if F is 20 Newton, how much force does block A press block B? So part A, so block A, force is being applied on F on A, and let us suppose this is the block B, and there will be normal between the two. Let us call that N. Frictional forces will be FRA as well as FRB. So in the first case, F is given as 20 Newton. So applied force is 20 Newton, and the frictional force FRA max frictional force FRA, which is nothing but FRA max, is equal to 40 Newton. So if you make a comparison, the applied force F is less than the frictional force. Applied force F is less than frictional force FRA, or we can say FRA max. Because of that, there will be no interaction. A block A will not move. Simply we can say that block A will not move. Therefore, there will be sufficient distance between the two. Or in simpler terms, we can say no force, thus block A will not exert any force on block B. This was our first part. In the second part, the applied force is now 50 Newton. Part B, applied force, that is F, is equal to 50 Newton. So, this is block A, block B. Now, F, we have FRA, okay, and we have to find out the frictional force acting between block B and the ground. Okay. So let us suppose that there is a normal, they are close to each other, so only difference will be, let me draw that again, because here applied force is greater than frictional force, so obviously block A will try to push block B. Here we can say applied force is greater than the frictional force, therefore block A will try to push block B. So under this condition, this is block A and this is block B. Applied force F, we have FRA and there will be FRB also here, and there will be normal force between the two. Okay. So you can write the equation for let us find out the value of the normal with respect to block A. So you can say that for block A, see block A, force F, we have FRA, and this is a normal force N. So we can write the equation as F applied force F is equal to our normal plus FRA max, because the block A is moving. So from here we can find out applied force is 50 Newton N, and maximum value is 40. So we get normal N is equal to 10 Newton. So this will be, with this force block A will try to push block B. This is the force with which block A will try to push block B. So we can draw the diagram for block B. For block B, this will be our block B and normal FRB. So here the value of normal, or rather we can say the force which is being applied on block B is 10 Newton, whereas FRB was 20 Newton. You can see applied force normal is 10 Newton and frictional force FRB is our 20 Newton. So make a comparison. Applied force is less than the frictional force. Applied force, that is value of N, is less than frictional force, that is FRB. Therefore, the value of the friction, thus the frictional force FRB will be equal to 10 Newton. So this is the value of the friction. We are supposed to find out acting between block B and the ground. This is the value of friction force acting between block B and ground. Okay. Now in the third part, we are supposed to find out the force of friction B varies with the applied force F according to the curve. So we are supposed to find out the curve with which the applied force varies. So before that, let's do the part D, because it will be required to calculate part C also. Let us start with part D. Which asks that what is the minimum force so that block B can be pressed against the wall. Okay. We can say that we have the value of Fr max is our 40 Newton and FRB max is our 20 Newton. So it states that block B should be pressing against the wall. For block B to be pressed against a wall, minimum force F minimum will be, ideally it should be less than equal to FRE max plus FRB max, or we can say F minimum is equal to 40 plus 20, so which comes as 60 Newton. Now let us do the part C. We have to plot the force of friction on B varies with applied force according to the curve. So we have to draw the graph for part C. Now there is no direct force on block B. Okay. Say there is no direct force that is being applied on block B. Okay. So from here we can say, now usually what is going to happen, the applied force first of all should be able to overcome the frictional force between A and the ground, and that is the maximum value of the friction, that is your 40 Newton, and only after that the force will be start to act on block B. Okay. And as soon as, and it is going to steadily increase up to the value where that force, which is normal, will overcome the frictional force between block B and the surface. Okay. This will be the graphical explanation. So we can say that the applied force F should overcome FRA max, which is 40 Newton. After that, force, which is normal, will start to act on block B. So partially we can say that this is our time and this is our force. So this will be the force. Yeah. Let us call this as frictional force FRB, and this is applied force F. So there will be a first point where this is applied force, or FRB is 40 Newton. So up till here the value of frictional force FRB will be 0 because there is no interaction between the applied force and block B. After this, the force will start to act on block B and will increase as applied force increases. So it is going to increase steadily, and this value we can see as the applied force is able to overcome the frictional force, the total frictional force, which is 60 Newton, so after that FRB will remain constant. So this linear will increase up till the value of 60 Newton, and then it will be a constant force. This is the basic. So up till 40 there is no interaction between block A and B, and after 40 it will increase linearly up till the value of 60 Newton, and then it will be a constant value of 60 Newton for FRB. So this completes the question. Thank you.